Now let's make this class Year E7 more interesting by adding some public methods. Here I'm showing what we already accomplished on the previous slide. The properties block is there, and the methods block is there with the constructor function shortened to only 3 lines. All of the details from the previous slide should be thought of as between the function declaration line and the end. On this slide, we're going to add several interesting public methods. The first method is called endDays, and it simply returns the number of days in the year by summing up the 1 by 12 m properties value, which is just the number of days of each month in the year. The next method, called char, takes the value of the year and using int to string converts it to a string and returns that. The method display uses the disp command in Matlab to give a simple formatted display of the year object. We'll also investigate how Matlab automatically calls this method under certain situations. Finally, n2dm converts a positive integer representing the day of the year into the corresponding day and month of the given year. We'll look at that code in a little more detail to see how it works. As an example, the 56th day of 2013 is February 25th, and that's exactly what that code will produce. Before we move on to some examples, notice that all of these methods that we just added have a year 7 object in their input argument list. This is one aspect of dispatching, which are the rules by which Matlab calls methods. We'll study that in a few slides. For now, though, I'd like to try some examples with this Year E7 class and these 4 new methods that we've added. But I'd like to do it in a slightly more structured way, creating actually 4 different versions of this class, where each one is adding one of the new methods beyond the constructor. The Year E7 C1 class will simply have the constructor and then the endDays method. The C2 class will be named differently. It will be C2. It will have the constructor, the endDays, and the char method. C3 will add the display method. And finally, C4 will add the n2dm method. Let's move to Matlab and look at these. Let's quickly glance at these in the editor. Here's the C1 has the endDays method. C2 has the endDays and the char. C3 has endDays, char, and display. And finally, C4 has endDays, char, display, and n2dm. Back to the command window. The command methods, along with the class name, lists the methods defined for that class. C1 has endDays, C2 has endDays and char, C3 endDays, char, and display, and C4 endDays, char, display, and n2dm, as we expected. Let's create an object of class Year E7 C1. Without the semicolon, we'll see the display. The method endDays works, but the method char does not. Let's construct an object with Year E7 C2, which adds the char method. endDays still works, and char is now a method. Class of that answer is char. Let's make an object of class Year E7 C3. Look what happened. The display has changed because of the display method. When we left the semicolon off, an expression that produced a Year E7 C2 object, we got this display. Here we left the semicolon off, an expression which produced a C3 object, and we got this display. The command display is what Matlab calls when semicolons are left off. Calling display on Y2, which is a Year E7 C2 object, and does not have its own display, we'll call a default display method. However, on Y3, which has its own display method, that method will be called, and hence we see this different display. Finally, let's make up a Year E7 C4 object. Let's see what its display is. As expected, since it implements the new display method. Before we try the N to DM method on Y4 to compute what day and month the 56th day falls on, let's go back to the slides and look at the code in detail. Let's erase most of this and just focus on the N to DM method. I'll use a different example than the 56th day. Let's try the 260th day of 2013. The cumulative sum produces this result. The next step is to find the first month whose cumulative sum exceeds the given day, which is 260. Counting over, that gives the 9th month, where the cumulative sum is 273. Therefore, the 260th day occurs in September. To determine the date within that month, subtract the given day from the number of days in all the months preceding the 9th month. In other words, the sum from 1 to 8. That gives 243 after the subtraction 17. Therefore, the 260th day of 2013 is September 17th. Let's do an edge case to make sure this is right. Let's try the 181st day of year 2013. Notice that that is the cumulative sum of the first 6 months. Therefore, cumulative sum first exceeds or equals 181, gives the 6th month. To determine the day within June, the given day, 181, minus the sum of all the days in the months preceding June, which is 151. That gives 30. The 181st day of 2013 is June 30th. Back in Matlab, let's make sure that N to DM works on objects of class year E7 C4. For the 56th day in 2013, February 25th. How about the 260th day of 2013? September 17th, as we computed. Finally, the 181st day of 2013. And that's June 30th, just as we had derived ourselves.